Should be going live. Alright, let's pop up the chat. Alright, now let's pop up Twitch chat. Alright, maximum sum array. I'm tired, so hopefully I'm not making a fool of myself. We'll see. Alright, so we're giving an array largest, find this array with the largest sum and return its sum. I kind of remember this. Trying to like get good at Leetcode again. I mean, not that I'm not good or that I wasn't good, but like review. So I feel that AI is like messing with my programming. So I don't know. I'm not logged in. All right, there you go. All right, let's go through the problem. Willing to embarrass myself live. Let's see. Okay, so we have this array. We know that the largest sum here is 6. So if this is negative, obviously we don't care about this. But we start with the 1. We wouldn't add the 3 unless the next one is a positive. What's the rationale here? I think that is like a win. I don't know if window is the right term, but so you start here and then you start like widening the window. You start to see if like a window has a larger sum. Initially, let's say that we have 0, I guess. Or let's say negative infinity, because any value will be larger. So negative 2, it's larger than negative infinity. then this value is -1, so that's a larger value than -2. Then this is if we add this, this is -5, so we don't want to add this. So what we do is that we start -1 is the value that we care for now. This is our max value. Then we start 4, so that's already bigger, so we discard this. So then we're here, -3 is not really I mean, technically we should discard this too, but we should take into account this, because that's 5, 6, and then here we have a lesser value than 6, so we know that here's our cutoff. And then we just go to the 4. So that's like the rationale. Yeah, I think I would use sliding window off the top of my head. Yeah, I think so. I kind of remember, like, so I've done this a couple of times, so I kind of remember the solution, but I want to solve it without solving it by memory. Because I have an idea of how to solve it, but I think I want to understand it at least right now before I start coding anything. Sliding window is definitely, I'm not sure if sliding window is the right term. I know that there's sliding window problems. I don't know if this is exactly a window, but like you need to, like I need to keep track of the values if I want to make sure that I'm able to run through an array and solve it. So, and the thing is, like I need to have like a some sort of running total and a current total, compare them, and then switch. But also, like, I gotta be able to have a cutoff. So I need to know, I need to keep track of indexes in order to start a new sub-array from that index. And I'm gonna grab this as an example. So for example, here I'm in index 0. So I wanna, if this is -2, well actually I'm gonna start my value with -infinity. So I don't know what it's, I know that's like JavaScript or Python. Let's see how to write to infinity, go math.infinity. Okay, so this is like -infinity. Okay. Do I want to write it? No, I don't want to write it on the terminal yet. Okay, any value will be larger. So I want to, if I want to keep track of indexes, I can do I, comma, nums. Do I want to check on the previous one? Not in this case, I believe. Uh, I want to use a, rather than a hash map, could be a hash set, either or. Let's think. Okay, so I have negative infinity, so initial negative infinity. So is this a larger value than negative infinity? Yeah, so we replace, well, that is our current, which equals -2. Then we have to do a check if current is bigger than max. Then we do a I mean, obviously we replace it, but I know that there's an additional operation. But okay, let's say that I go into the next number. Let's say I have to keep track of some. So if I go into the for loop, so for nums I, then I have a feeling that I would have to do something like that. Also for each iteration, so I only have to return the sum. I don't care like what the subarray is. I just need the largest sum, which that should be stored in like a max variable, which I have it here. So let's say max. So I'm not gonna put initial. I'm just gonna put max equals negative infinity. So I mean, the idea behind this is that current should at some point be larger than max if current has more positive values. But then if current, if this doesn't happen, I feel that then the subarray has to start from whenever current is negative, or so like for example, let's say that we also have a map, hash map. I don't know how you write it in Python, I forget, but is it like key value And maybe instead of bool, where I have like maybe, let's say index 1 and then the sum 3. I forget, but let's go with that. Then this would be an integer. Okay, let's keep on seeing. Okay, so I mean, that's the idea. So for example, if I start here, then I think it should be 0. Or whenever current is larger than max, that means that whatever I had previously doesn't work, which means that I have to start a new subarray from that current. Meaning, okay, so let's say that I start from negative infinity. So I see -2, so whatever I had, then scratch that, I start the subarray from 0. Then I see the next one, and then I believe that the sum maybe will have to like reset to 0. Let's say that I start from here. This is larger than our current max, so now I say scrap, starting our subarray from index 0, let's start from 1. So then I go here, and this is my current. Is this larger than max? No, keep on going. Is this larger than max? It's actually equal, keep on going. Yeah, then I would have to keep on going until I reach the end. There has to be a caveat there. I mean, that's +1, then -1 is 0, then plus, okay, this is larger than max, because we have a total of 2, right? We have -3, -1, and then we have +4, so that's 0, and then the 2 is just +2. So that's larger than 1. So we can say that we start from here, we point to this new index. No, but that doesn't make sense. We could also done the same with 4. Or yeah, we're 1. Sorry, I actually mixed up myself. All right, let's start from scratch. -2, larger than infinity. Boom. Start on the next one. 1, larger than -2. Start from this index 1. We go here. All right, the condition for whether keep on going or not, I don't have it right. I have to make a clear condition on when do I move to the next subarray, and when do I keep on going adding more. If I'm thinking out loud, I should move on to the next index if whichever value I'm currently looking at is negative. That's 1. And the running total is not larger than max value. Okay. Also, maybe I don't need a hash map. Or a hash set. I don't know. We'll see. I don't think I need one. Alright, I'm gonna give myself 15 minutes and then I'm gonna see a hint. So let's put 15 minutes. Alright. So let's delete that. Sum, max. Wait, does this say? Okay, so ON, so this can be done in linear time, so in one pass, so everything within one loop. I mean, I kind of remember how to solve it, but I don't want to like solve it by muscle memory. But we'll see. If by 10 minutes, then I'll try to do it by muscle memory and then understand. But the idea is that like you want to be able to keep somehow a sum of the running total and compare against the max. Where did I put num? Should be num. Max, I'm gonna put some. So this is just a max function that I'll be using here. Hey, what's up, Jams? How's everything going? ¿Qué tal todo? ¿Cómo va? Let's see. I mean, some actually would be the initial. Do we start with the initial? And then if so, should I then start from the index 1? I mean, I'm kind of remembering how to solve it. But okay, so so you have the current sum. From what I remember, so you have the current sum, and you have the number by itself. So what do I mean by that? So for example, you start here. This has to be your sum or current sum, whatever you want to call it. So I'm actually gonna let's do the following. Current sum, then num. We'll get rid of this. Max, I believe this actually num 0 from what I recall, but could be negative infinity. We'll see. Then we have our max. So essentially, current sum. You want to compare, so you want to compare the current number versus the current sum plus the current number. Why? So for example, you will have negative, let's say we start from actually 1 because this is already accounted for. So we have 1. Is 1 bigger than 1 plus, is 1 and negative 2 bigger than just negative 2? Yes. And then we have max, which max initially starts at negative 2. So we do our largest. It's kind of like a window. I don't have a pointer, but it is kind of like a sliding window. So I'll put here largest, so it doesn't get confused with like the max function. So then I would do current sum or max, and then return. Well, then go through the whole for loop, and then, you know, at some point, if I see a negative 3, what's largest? Current sum or negative 3. I mean, negative 3 is larger than negative 4. But then this will be discarded at some point because we'll just look at 4. 4 is larger than negative 3. So we'll use negative 4. And we'll put negative 4. And then next round we'll keep negative 4 or 2 negative 4. 2 plus 4. But my question is how I need to add this. I need to somehow also account for the negative 2, because right now it's 6 if I don't take account, and then the next one will be 7, which is wrong. So somewhere here I'm missing something here, but I think I kind of have it. All right, so let's start with that. So num0 is largest. I'm gonna put largest. Then I'm gonna put current sum equals. I guess I can start with that too. And then I can say current sum will change to either current sum or current sum plus num. I guess I can get rid of this. And then max, I mean, I need to adjust it, but let's add this for now. Max equals current sum or max. So I need to adjust this. I'm not taking account of something here. Return largest. Because actually, let's put that here, because I just want to see. Okay, so let's run the algorithm. So first value is -2. I'm saying -2 or -2 plus 1, so that's -1. So current sum would now be -1. Then -1 or -3, we keep -1. And then this becomes -1. Then 4 -1, well, 4. And largest also becomes 4. Then 4 or 3, we keep 4. But that's the thing. I need to account for the, in order to later have this 6, if I don't keep count of that. Current sum. Like either I do it in the largest variable or I do it in the current sum, but the thing is that I have to add those differences. And like keep like a sliding window. I know I'm not being very self-explanatory, but what I'm saying is that either I have to do a max here and then a max plus current sum. Like I do the addition here and then here, then I check like so, or vice versa. And it seems that before I'm not keeping count of like the whole run in total. Because like for example, this scenario, obviously 4 is the max value. But if I go to the next one, I need to somehow keep count of 3. Like it has to be 3. So how do I keep that 3 persistent throughout the rounds? Through the rounds, sorry. So what's larger? Current sum plus num, maybe? Or num. That makes more sense because this will still decrease, but 3 is larger than -1. So I feel that's like a way of keeping track. I think you were almost there. You just had two small issues. Let me see if I find it. Don't tell me any hints. I think I'm almost there. So then I have. So I think this is keeping track of the running total now, I believe. And then so we have max, which is 4. Or let's say that I have 3 and before, like it was 1. So before it would keep track of 4 if I would start here. So it would have to be current sum. Because at some point, current sum will go back to 5. And then at some point, current sum will go to 6. So I think this is the way it should be. Let's see. Oh shoot. What did I miss? Missing import path solution goal. Is it because of this? Let's see. Can I use max function as int value in argument max? Wait, what? Oh. Largest. Yes. I kind of remember, I'll be honest, but like I haven't done it. You can see the submission. Like my last submission was February. So, and it was in TypeScript. I think I haven't done this in Go in a while. February. Oh, okay. Still. So there you go. Just so you see that I'm not cheating or I've done this like before this stream. Well, actually, I haven't submitted. Let's submit it and let's see it, that I don't get any errors before I like keep talking trash. Ah, feels good. Okay, sweet. So yeah, before this submission, my last submission was on February. So yeah, did not do this before, and I got it right before the timer. Nice. Which is a sliding window. This is a way of doing a sliding window. So yeah, I don't know why I started with the map, but this works, which is nice. I didn't, to be honest, it's not cheating, but I've done this before, so I understand the problem. I didn't check edge cases, which I should have. So I gotta be more meticulous about this. I feel it covers the edge cases though. If all the numbers are negative, then I'll just return the smallest negative number. Or the least negative, rather. Yeah, so even though I wasn't like too careful to like test negative test edge cases, I think it still accounted for everything. So, yep. Now I'm gonna code this in Odin. Should be very similar. Sliding window. Sliding window. And what's it called? Max sub array dot Odin. Max sub array. This returns an int. And there should be blah blah blah. What was it? Largest. Largest current sum. Then I don't remember the Odin syntax that well. Let's see. For let's see. I feel like you could do that for num and nums. And then we want to have a utils dot Odin package utils, and this is max proc a b int. Oh, I remember. Yeah. Okay, so if a is larger than b, return. Wait, can I do this in Odin? No. Worth a try. A else return b. For INX, right? Yeah, that's what I thought. For num and nums should be. I think I can do this. We'll see. We'll see if this works. There's max function in std as well. Oh, no way. Okay, that's nice. So I can get rid of the utils. So the algorithm, we said that. Oh wait, I know I also want to make a slice here, so I think I could do something similar. Current sum is equal to max, and it's current sum plus num or num, and then largest equals max. Current sum or max, return. Alright, I think that was it. Okay, that is gone. Oh yeah. How do I do import again? Damn it. For value nums, okay, that's fine. And then import packages in Odin. Okay, so I can name them. Okay, for now I'll do that. And then test nums. What is it? Oh. I mean, what? Max sum. Okay, Odin run. Should be 6. There you go. Sweet. Okay, so add git commit initial problem solved. Okay, cool. So that's one. Now I gotta cross it off here. What was it? Maximums of array. Done. True. Okay, so now let's choose another problem. Oh, Leetcode Premium. Yeah, I'm not paying for Leetcode Premium right now, so let's do another one. Meeting rooms. I like that one. Oh shit. Leetcode Premium too. Okay, so I don't want to see the solution, but let's see if I can get the problem here and then solve it on my editor. Consider start end times. Determine if a person could attend all meetings. This is an easy one, isn't it? Like essentially, you check that, like the next, like this is not in between the beginning. Rather, you gotta sort, and then you gotta check that this initial is not smaller than the ending once they're sorted. And you sort them by initial time, like so. So for example, if it would be only this 2, the person would be able to attend all. But since this is from 0 to 30, and you can think of 30 as like, I don't know, minutes, whatever. This 5 goes in between 0 to 30, therefore he cannot be at the same meeting like this length and this. So yeah, I'm gonna move my head a little bit to, yeah. So yeah, this is not valid, but this is valid. I think that's the solution, but I don't have Leetcode Premium to run this, so damn it. Yeah, this is an easy one. Whatever. We'll do another one. Longest common subsequence. I'm gonna choose another one. I don't want to do that one right now. Spiral matrix. All right, whatever. I cannot keep dodging questions. Spiral matrix. Actually, I may need to go soon, but I'll start attempting this. I don't want you guys to think that I'm backing away from a challenge. Okay, so given M by X matrix, return all elements of the matrix in spiral order. Okay, this is not too crazy, right? So you gotta do a for loop where, well, you gotta do like 2 for loops, one outer, one inner, and you have to keep, you gotta decrease the range and you gotta change direction. So those are the only, yeah. So this is not too hard. I mean, I'm saying that right now, but so let's put our notes here. In spiral, we need for loops in different directions, clockwise, right? Yeah, that's clockwise, and reduce the range of iteration until range is equal to 0, right? Because once we reach the center, then we're done. Yeah. I mean, if this is a 3 by 3, but I remember there was a case when there's 4 by 4. So let's imagine that there's one more row here, then 4 more here. So it'd be like 4, like 4, then 3, 3, 2, 2, 1, 1. Then you're done. And here it's like 3, 2, 2, 1, 1. So it seems that it always reaches 1. And if let's say that is like a 2 by 2, so let's say 1, 2, 5, 4. So 2, 1, 1. Okay. So it seems that if you notice, it goes by pairs at some point. And when it reaches 1, then there's no like 0, 0. I don't know if I'm explaining myself well, but let's say that there's a 5 by 5. So let's say that there's a 5 by 5. So 1, 3, 4, 5. I'm gonna put it like that for ease of like drawing. So 5, 6, 7, 8, 9, 1. I'm just gonna repeat numbers because I don't want to like write 2-digit numbers. And then I'm missing one more row and one more column. Okay. So what I'm saying is like, okay, 1, 2, 3, 4. Okay, did I print 6? Damn it. So it goes 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Then 3. 1, 2, 3. 2, 3. Then 2. 1, 2. 1, 2. Then 1, 1, 1. And we're done. So how do we know that from here we need to do 1, 2, 3, 4, 5? We need to do one less of whatever this is. One, 2, 3, 4. I mean, one less than like total minus 1, 2, 3, 4. 1, 2, 3, 4. I mean, I have the algorithm. It's just like now, okay, the logistics of like reducing. So first round will be from 0 to row minus 1. Second round to I'm gonna put matrix. Essentially that is 0, or I'm gonna put I dot length minus 1. Right, because we want to go all the way here. It'll stay in the same row, but this will be changing the column location from column 0, column 2, column 3, column 4, column all the way to column like minus 1. Now in the second round, instead of doing columns, we're gonna be changing the rows. So we'll be doing from row 0 to Jesus. Matrix. Huh. Row I. Right, this will change. And then this will keep fixed. The I and then column. Well, I is less than row -1, right? Or yeah, the length of like whatever this array is. And then wow, I is, well, I or J, whatever. And then we need to change direction, so third round. Oh my god, that's gonna be a doozy one. Let's put a timer. I'm gonna put 10 minutes because I want to go to sleep in 10 minutes. So third round, I want to go in the opposite direction. So I'm gonna do from mat row I -1 to 0 while finish or while end is larger than 0. And then when we go upwards, fourth round. Because at least there's 4 rounds. Even in a 2x2. 1, 2. Well, actually no. Shit. If I have a 2x2, there's 1 round, 2 rounds, 3. There's no fourth. Do I see a hint? I'll wait 2 minutes to see a hint, because I mean, is there linear? I'm guessing none. I'm guessing it should be quadratic, like squared, sorry. Well, quadratic square. M is equals to the matrix length, and is okay, sure. So you like, we won't get a matrix that's larger than 10 by 10, which should be contained within like 100 values. Okay. I mean, I'll start simple, just like traversing through the matrix. So for I is equal to 0, as long as I is less than matrix I feel that I'm not I mean, that is gonna give me an array, so that makes sense. Matrix. I feel that it should be like so. Because the first one will just give me how many arrays the 2D array has, or how many rows, and then this will give me like the length of a single row. Which at the end of the day, like if you have the length of one, they're all the same. In this case, I do have to like keep reducing, but just to print a normal 2D array. I'm gonna copy this for ease of use. Wait, do I have this in Go? So let's get rid of that. Let's get rid of that. Let's put a matrix. Matrix. It should be a 2D array. Actually, let's see if I can do substitute. That didn't work for shit. Alright, whatever. I'm not gonna do the Vim tricks right now. I'm definitely not doing something right on Vim, but I just want to try this. Imports are not used. Alright, I'll get rid of that. So now I can print the matrix. Okay. Let's do go run main.go. Oh, duh. Print matrix ij. Alright, so we're printing everything, so I'm not that lost. I have to change direction. How do I change direction? Oh wow, I have 2 minutes left. I mean, I know that if I reach this, instead of going this way, I just change direction. So if I want to print downwards, let's say I want to print 4812, for example, or 369. I would have to do Well, first of all, the column would have to stay static. So that would have to be like that. And then the column would keep increasing. I'm gonna get an error at some point because it'll be out of bounds. So okay, so I'm doing 147, 258. So I'm printing now this way: 147, 258, 369. So that works, but it means that this cannot be static. So I need to change this depending on like whatever. Also, I need to keep track of this because I also need to be updating this. So so I need to start keeping track of calls matrix 0. So that should give me the number of subarrays. And then this should give me the number of values within an array. And if, since all the subarrays have the same length, because they're all like the matrix will always have the same number of columns, then I can do this safely. Now, do you agree that every time you run one of these, you have to decrease whatever this value is? So what I mean by that is that if I'm taking into account, if I'm printing columns which are 4, the next iteration, which is when I get here, now I have to do 3, right? Because I do 1, 2, 3, 4, but then I also run this 1, 2, 3. So now I have to start from here, 1, 2, 3. Then I do 1, 2, and then I have to do 1, 2. So I do 4, 3, 2, 3, 2. So that's why I have to keep track of this, so that way I can do row plus plus, row calls, rows negative less less, and calls less less. And then I need to be able to flip direction as I need to. So not like this, I know. So I would have to do how do I flip direction? How do I flip direction? I don't know if it's here, but I have to do something like that. Return all the elements of the matrix in spiral order. So I can put them in a result array. Alright, I'm gonna start looking at hints. This is released to come up with some algorithm for a simulation. Basically, you need to simulate what the problem asks. Okay, that's not helpful at all. That's all. It's all the simulation that we need. Yeah, it's switch the progress, that I know, on one index. If out of I, j, you'll still shift the same column certainly by changing values. Should you be shifting in the same row? The end of the boundary so you can move. Okay, so I also have the end of the boundary here. Okay, so all of the hints, I kind of have them. Now it's the implementation. Switch direction, switch direction. Alright, so let's think of this. So going left to right is if I do matrix I, J. Going up to downwards, it would be matrix the row changes, I would stay the same within the same, but then I only need to print once, not the whole thing. I remember there was like something like that. Let's see. Well, I don't know if this will always hold. This I'm just like, yeah, okay. I Alright, I think I'm gonna stop in 4 minutes. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want to print 1, 2, 3. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's fine. So now I want to print 1, 2, 3, 6, 9, 8, 7, 4, and then 5. And I can do something like yeah, okay, so that's very visible. Okay, so I have that. Now I want, once it reaches the end, I want the column to stay static. If I want the columns to stay static, means that I don't want this to move, but I do want this to move. And I have no. I don't know, man. Okay, 1, 1. Okay, no. I'm very tired. I think I'm gonna stop here. Yeah, this couldn't solve it. So at least you saw one solved solution and one non-solved. I don't know. Let me know what you guys think about these streams. Do you like me solving Leetcode? Do you guys just want to see me? Because I've solved this before. I have the solution when I did this. But yeah, definitely. If this would have been an interview, if I would have not gotten guidance, maybe I would have not passed. I don't know. I think I have the idea. It's just like right now I'm blanking out on how to make the switch from going to here. I mean, I know that if I switch J for I here, so if I do that, and if I do that, I know that it's gonna print going like that. But now I want to make the column static, which I don't know if I should do like something like that. But obviously now this will always print here, and then if I go to like what is it, rows length, then it'll always still stay here. If I do like not rows but like what is it, len matrix, right, then it'll always stay here. So this has to be dynamic, I don't know, -I. But then at some point, once it reaches whatever, then it has to like flip again. So yeah, I need to think of that, like of those flips. But anyway, thank you guys for tuning in. I'll see you guys in the next one. Peace.